video, we will discuss about imaging SPS, electron microscopy, scanning probe microscope, and ultra depth profiling.
Hi, today I'm going to present about XPS imaging. What is XPS imaging? XPS imaging is a combination of the departures of X-ray photoelectron spectroscopy with a spatial localization. There are three imaging system strategies for obtaining spatial localizations. First, localizations by selected limited area analysis. Two, localizations of the probe by focusing the incident X-ray. And three, use of the X-ray detector with associated imaging optic. First is the limited area analysis. This method is the simplest approach of localizing XPS analysis to restrict the area of surface from which photoelectrons are collected using a combination of lenses and apertures in the design of the electron energy analyzer. But what is the main problems of this technique? When using this technique, the sample area is reduced, so is the collected signals. Consequently, there is a direct trade-off between a spatial resolution and data collection time. 2. Imaging SPS by X-ray focusing. Until very recently, this technique was not popular options in commercial instruments, since the X-ray are rated difficult to focus. But now these are different. It's different because an X-ray spot size of greater than 10 micrometer has been achieved using this approach and significantly has a better resolution. Image might then be obtained either by scanning the sample under the focused X-ray beam or by scanning the microfocused X-ray beam. This is the example of the spectrometers that using this technique. Third is the array detector and imaging optics. There are a lot of design for imaging spectrometer which combine with array detector with sophisticated imaging optics to get electron energy resolved image at a faster acquisition rate. The spatial resolution achievable using this approach is higher than other techniques. This is the example of spectrometers for this technique.
What is electron microscopy? Electron microscopy is a technique used in the characterization for the study of surface morphology and elemental composition. The two forms of electron microscopy which are commonly used to provide surface information are secondary electron microscopy (SEM) and scanning wajihah microscopy (SAM). The purpose of SEM is to provide a direct image of the topographical nature of the surface from all the emitted secondary electrons. How does SEM works? Firstly, the electrons are generated at the top of the column by the electron source, which is a heated tungsten filament, and then they accelerated and attracted by the positively charged anode. Then it later enters into the condenser lens. Next, the electrons will hit into the scanning coil, and then via scanning coil it hits the sample. Two types of signals are detected, which are backscatter electrons and secondary electrons. Lastly, the image of the sample will be displayed at the computer. The scanning wajihah microscope produces elemental maps of the surface by scanning the electron beam over the sample and selecting specific object peaks. For SAM, the incident primary electrons cause ionization of atoms, and then the ionized atom leads to the emission of OG electrons characteristic of the elements present in this part of the sample surface. There are two types of scanning probe microscopy, which are scanning tunneling microscopy (STM) and atomic force microscopy (AFM). STM works by scanning a very sharp metal wire tip over a surface, and by applying an electrical voltage to the tip or sample, image can be seen at very small scale. The first principles involved in STM is tunneling, where it is an effect of the wave-like nature, and second principle is piezoelectric effect, where it is resulting in the creation of opposite charges on the sides. For AFM, it uses a cantilever with a very sharp tip to scan over a sample surface, and when the tip approaches the surface, force will be produced, and then various samples can be imaged.
Hi, my name is Zulfariez bin Harun. I will talk about the depth profiling. So, what is depth profiling? Depth profiling is a process where the element or chemical content of a sample is measured as a function of depth. The aim of depth profiling is to obtain information on the variation of composition with depth below the initial surface. Such information is obviously used for the analysis of layered structures such as those produced in the semiconductor industry. There is many analysis techniques that perform depth profiling. Use a beam of ions such as argon ion, gallium ions, and caesium ion. Other depth profiling techniques are pulse of laser light, plasma beams, glow discharge, or confocal manipulation of the sample in the z-axis. The depth profiling process involves the repeated removal, or in certain cases, the removal of the sample down to the desired depth that we want. To obtain information about the variation of composition with the depth below the surface of a sample, it is necessary to gradually remove material from the surface region being analyzed, whilst continuing to monitor and record the Auger spectra. This controlled surface etching the analyzed region can be accomplished by simultaneously exposing the surface to an ion flux, which led to sputtering, which is removal of the surface atom. This is the Auger spectroscopy that is used in Auger depth profiling. In its base form, it provides compositional information on a relatively large area of surface using a broad focus electron beam probe. If it is broad focus, sufficient signal can be readily obtained while keeping the incident electron flux low, by avoiding potential electron-induced modifications of the surface. So, because of that, the technique is non-destructive. To obtain information about the variation of the composition below the surface of the sample, it is necessary to remove material bit by bit from the surface region that is being analyzed, in order to continue monitoring and recording the Auger spectra. Surface etching can be accomplished by simultaneously exposing the surface to an ion flux, which led to sputtering of the surface atom. In summary, collecting Auger spectra as the sample is simultaneously etched by the ion bombardment, it is possible to obtain the information on the variation of the composition with depth below the surface. This technique is named as the Auger depth profiling.
We would like to express our gratitude to our lecturer, Associate Professor Dr. Zaidi, for giving us opportunity to do this assignment. Next, we want to say thanks to our beloved friends and family for the support. Last but not least, We would like to thank for our group members for their commitments in completing this assignment.